Hello and welcome to the video presentation of Methods Time Measurement in Layout Design. My name is Michael Morrow, and in this presentation we will introduce how Methods Time Measurement, or MTM, can be used in assisting the design of factory and warehouse layouts through the use of a case study. Firstly, an introduction to myself and Tomorrow Solutions, the company I founded. I'm an industrial engineer based in Queensland, Australia. I graduated as a professional engineer in the 90s and worked as an industrial engineer for approximately 14 years in the lighting, bedding and door hardware industry. During that time, I was exposed to factory layout design, assembly line balancing, engineered standard time development, Kanban implementation, quality management systems and project management. For the last 6 to 7 years, I've been consulting to small to medium enterprises, primarily in Queensland, to improve productivity through training in lean management and assisting organisations implementing their lean initiatives. At Tomorrow Solutions, we focus on productivity improvement. Through a holistic approach, we assist companies in applying best practice by offering the following services: lean audits, tailored training in lean management principles and implementation of lean management in organisations; process mapping workshops, utilising process charting and value stream mapping techniques; training and coaching in the implementation of the 5S housekeeping and organisation system; facilities layout design for offices, factories and warehouses; work measurement and methods analysis utilising the MTM-2 predetermined motion time system; process documentation such as work instructions and procedures; visual performance measurement, working with organisations to develop meaningful key performance indicators and applying visual management techniques to engage employees and other stakeholders. First of all, let's quickly introduce MTM. MTM focuses on the manual motions used in a process. It's a procedure which any manual operation is analysed into the basic motions required to perform it, and assigns to each motion a predetermined time standard, which is determined by the influencing factors, for example, the distance reached and the degree of control under which it is made. In the original system, MTM-1, the basic motions are reach, grasp, move, position and release. For simplicity, a second generation MTM system was developed, MTM-2, where the basic motions have been combined into motion sequences get and put. In this presentation, we will be focusing on the application of MTM-2 in the layout design process. In this case study, the client approached Tomorrow Solutions to assist them in designing a new layout to relocate their warehouse and manufacturing processes to a new site. The objectives included centralising their national warehousing capability to a new site in Brisbane, Australia, in conjunction with their manufacturing facilities. A competitive advantage of the client is the ability to provide kits to their customers, and a requirement of the new layout was to incorporate a streamlined kitting process utilising one-piece flow and 5S housekeeping principles. The management of the client have had previous experience with MTM-2 and requested that MTM-2 be utilised in calculating one-piece flow requirements and also for calculating the centralised warehouse capacity projections. A layout project team was formed, including key staff in the layout development process. After the layout objectives were reviewed and documented, a process mapping analysis was conducted. Firstly, a value stream mapping analysis was conducted to provide a less detailed, holistic view of the manufacturing and warehouse operations, identifying the material and information flow required and opportunities for improvement. After brainstorming, a future state value stream map was drafted with improvements including a kitting cell, adopting one-piece flow, and Kanbans. In conjunction with experienced warehouse staff, an in-depth process mapping analysis of the warehouse picking and kitting process was conducted, utilising the flow process charting method. The flow process charting method is used to break down the process into 5 basic categories. Operation, a task required to intentionally transform a part. Examples include driving a nail or drilling a hole. Transportation, the movement of a part from one place to another. Examples include moving material by truck, conveyor or by carrying. Storage. A part is stored and protected against unauthorized removal. Examples include bulk storage, pallet racks, filing cabinets. Delay occurs when a part is not immediately permitted to be processed at the next workstation. Examples include material in a trolley waiting to be processed, papers waiting to be filed. Inspection. This takes place when a part is being examined to determine its conformity to a standard. Examples include examining material for quantity or quality, reading a steam gauge on a boiler, examining a printed form for information. The flow process charts identified the process elements of the picking process and the kitting process for the various products manufactured by the client. These process elements were analysed in detail during the subsequent MTM-2 analysis. Following the completion of the process mapping, an MTM-2 analysis of the warehouse picking and kitting processes was conducted. This involved, firstly, video recording the picking and kitting processes, reviewing the video footage and identifying the elements identified in the flow process charting analysis. These elements were broken down further into data blocks. An important aspect of the modular approach of MTM-2 is that data blocks are generally repeated in different processes, saving analysis time compared to the traditional time study approach. MTM-2 motion analyses were conducted for each data block. For each data block, the MTM-2 analysis, we documented the layout of the process, identifying the position of the operator and how many steps were taken to perform the operation. We documented the equipment used, including consumable items, jigs and fixtures. The weight of the items used were also documented. We determined the motion sequence and MTM-2 code for each element used for both left and right hand, taking into account the distance the hand is moved and the degree of control required. We assigned the predetermined time values for each motion sequence code. We added all of the time values for a total process time. The process times, calculated from the MTM-2 motion analyses, were summarized in an MTM-2 data block summary table. This table includes all data block variations. Thanks to the modular approach of MTM-2, the times resulting from variations can be predicted and calculated without having to resort to conducting time studies or educated guesses. These variations in data blocks may include variations in product dimensions, weight or features that affect the time to handle or process the product, or layout dimensions. Variations in layout can affect the number of steps required by the operator. Each data block is assigned a unique code to enable identification. Each data block has a description of the motion analysis in plain English, derived from the MTM-2 motion analyses. As identified in the layout objectives, the layout of the kitting area was redesigned, utilizing one-piece flow and 5S housekeeping principles, and incorporated into a production cell layout. To achieve one-piece flow objectives, a line balancing analysis was conducted for each major product group that is currently kitted, utilizing the data blocks determined in the MTM-2 analysis. Based on the line balancing calculations and discussions with experienced operators, the kitting layout was drawn utilizing one-piece flow and 5S housekeeping principles. Spreadsheets were developed for calculating the standard times of the revised kitting processes, in addition to the warehouse picking process, incorporating the data blocks and fatigue and delay allowances. The standard times were used for calculating the number of staff required for a projected increase in warehouse picking and kitting due to the centralization requirements of the new layout. For all work centers identified in the value stream mapping process, space envelopes were developed by the factory layout project team, except for the optimized kitting work center. The space envelopes contained the space required to productively perform the task at the work center. For example, loading and unloading space, equipment footprints, tool storage, workbench space. The factory layout project team conducted an activity relationship analysis. also known as closeness relationship analysis, where each work center was rated in terms of closeness to each and every other work center in the layout. The ratings, in conjunction with the reasons for each decision, was documented in a matrix. The floor plan of the new site in CAD was obtained from the client, and the work center space envelopes were added to the floor plan, based on the workflow identified in the value stream mapping process. Information from the activity relationship analysis was applied to the layout drawing to review the optimal positioning of each work center based on closest relationships, with adjustments made to the layout when necessary. Alternative layout options were considered and reviewed by the layout project team. We're coming to the end of this video presentation. The purpose of this video is to demonstrate how the use of methods time measurement can be combined with a methodical approach to layout design by example of a case study. By aligning MTM to the process mapping used in the preliminary stages of layout design, the detailed approach of MTM can assist in improving the layouts of work centers, also known as micro layouts, and accurately predict the process times and labor capacity for these improvements before the layout has been implemented. In fact, using MTM we encounter first time right, as it becomes easier to bypass iterations of layout improvement by determining the best method before it is implemented. That's something to think about.